So let's learn about naming of IUPAC names of organic compounds. Now to name these compounds, there are some important rules that needs to be followed. So let's take some examples. Let us now begin with the first example. Now to name this compound, we first need to find the longest continuous carbon chain, and here in this first example we have two carbons. So first of all, let us name it forward and backward. So the naming would be 1 and 2 here. If I'm starting from the left side, and if I'm starting from the right, it's going to be 1 and 2. So here I've named these carbons in two different ways, one from the left side and one from the right side. So one is termed as forward, which I have started from the left, and the second one from the right is called the backward numbering. So let's talk about the backward numbering later. Now, this compound, in this first example, has got two carbons. And as we know, if there is one carbon, the name starts with meth. And if there are two carbons, then it is called eth. If it's three, it's prop. If it is four, it's but. And if it's five, it's pent. Now, in this example, as I said, there are two carbons. So this one has to start with an eth. So we're going to name it as ETH to begin with. Now, as you can see, the carbon compounds. Here, what type of bonds actually are establishing between the carbon atoms here? And as you can see, here there is a single bond. So this hydrocarbon is actually an alkane. So the name of this structure will now be ethane. So for this organic compound, the IUPAC name would be ethane. I hope that you understood the first example. So now let's take the second example. So first of all, in this, let's find out the longest continuous carbon chain in this example. So to begin with, let's start the numbering of this. So I'm first going to start the numbering from the left side. So that would be 1, 2, and 3. And if I start with the backward numbering, it would be 1, 2, and 3. So here the total number of carbon atoms in this structure are 3. So its name should begin with a prop. So first let's name it as PROP because of the presence of 3 carbon atoms in this structure. And now, as you can see, between the first and the second carbon atom, there exists a double bond. So existence of a double bond clearly indicates that it should be an alkene. So as it is an alkene, the name of this organic compound would now be propene. So before you actually name a hydrocarbon structure, we need to look at the carbon chain and the bonds that exist between the carbon atoms. As in the first example, because there exists only single bonds between the carbon atoms, it was an alkane. And in the second example, as there existed a double bond between the first and the second carbon atom, we named it as propene. I hope you understood the second example as well. Let us now watch the third example very closely. As you can see, in this organic structure, there are 5 carbon atoms. So let's start numbering it from the left side first. So it would be 1, 2, 3, 4, and 5. And if I start the backward numbering, that would be 1, 2, 3, 4, and 5. Now, as you have noticed, there are 5 carbons in this entire structure. So because of the presence of 5 carbons here, we will now name it as pent. Secondly, if you look at the presence of bonds here between the carbon and hydrogen atoms, all the carbons have an attachment of a single bond with the hydrogen atoms here, thereby clearly indicating that this has to be an alkane. So this structure would be called as a pentane. A very interesting thing to notice here is no matter if either you start numbering it from the left side or the right side, the number of carbon atoms are 5 and has got equal attachment of hydrogen atoms here. So here this structure can now be called as pentane. I hope you understood this example. Let us now look at the example number 4. As you can see here in this structure, there are 4 carbon atoms. Now let's start with the numbering from the left side. That would be 1, 2, 3, and 4. And if I start the backward numbering, that would be 1 here, 2, 3, and 4. So here in this structure, we have 4 carbon atoms, and the presence of 4 carbon atoms clearly indicates that it is a bute. So here in this structure, let's ignore the CH3 for a moment and let's go ahead with the number of carbon atoms. So as there are 4 carbon atoms present in it, this should be a bute. And because the bonds existing between the carbon atoms are all single bonds, it is going to be a butane. Now, coming to this CH3, this attachment to the second carbon atom. So as you can see, it is CH3. So what does this represent here is an alkyl. So why it is an alkyl? Alkyl basically is alkane minus 1 hydrogen. So alkyl is equal to alkane minus 1 hydrogen. So if that would have been CH4, we would have called it as methane, but now that it is CH3, we are going to call it as methyl. So alkane minus 1 hydrogen is alkyl. So CH3 here would basically now be called as a methyl. So methyl will be written as a prefix to butane here. Now, after this, we also have to number the position of the attachment of methyl to the carbon atom. So we will now consider the smallest number to which the CH3 is actually being attached. So if you can see, methyl is attached to the second carbon atom. If we would have considered the backward numbering, then that would have become the third carbon atom, which is against the rules. So we will first have to look at the smallest number of the carbon atom to which there is an attachment. So it is now going to be 2-methyl butane, because here methyl is now attached to the second carbon atom. Hope You would have understood this example as well. Making a small adjustment here in this example, if there is another CH3 attached here. Now, as you can see, there are two methyls attached here in this structure. Now, if I consider this attachment from the left side, the CH3, that is the methyls, are now attached to the second one from the left side. And if I consider the backward numbering, here too, it is attached to the second as well as the third one. So now, here because we have two methyls been attached, we are now going to write it as dimethyl butane. And here these two methyls are attached to the second and third carbon atom. So we're going to call it as 2,3-dimethyl butane. Hope you have understood this example as well.